Hello everyone, welcome back to Sulekha Physics classes. Hope you all are good and well, right? In the previous video, we had discussed about basic mathematics like algebra, trigonometry, geometry, coordinate geometry, all these things which you already studied in class 10th. Now today, there is one new topic for you, that is calculus, in which integration and differentiation we will cover, right? But before starting calculus, one important topic in trigonometric is left. That is very important. So I'm going to discuss that one first. Then after that we will start calculus. In that one first differentiation. Okay. In trigonometry, trigonometric ratios. We already discussed all these things. But there are 4 quadrants, right? This one is first quadrant. This one is second quadrant. This one third. And this one fourth quadrant, right? Here angle 0 starts, and when we move in anti-clockwise direction, you always take angle as positive, and when you move in clockwise direction, we always take angle as negative, right? So starting from this 0 degree angle up to this 90, then this one 180 degree, and then this one 270 degree, again come back to its original position 360 degree. You know all these things, okay? Now one thing you have to keep in mind, that in first quadrant all trigonometric ratios, I am going to write here A means all trigonometric ratios are positive. In second quadrant only sine is positive, right? In third one only tan theta is positive, and in fourth one cos theta is positive, right? In first quadrant means which is angle between 0 to 90 degree. Second quadrant means angle means between 19 to 180 degree. Third means 180 to 270 degree, and fourth quadrant means 270 to 360 degree. Now when anything is given, any angle is given, first you have to find in which quadrant that angle lies. After that it's very easy to calculate the value of that angle, okay? So there are some values which you have to remember. Sine 90 minus theta, cos 90 minus theta, tan 90 minus theta, then sine 90 plus theta, cos 90 plus theta, then tan 90 plus theta. After 90 degree, I will write about 270 degrees. Sine 270 minus theta, cos 270 minus theta, tan 270 minus theta, then sine 270 plus theta, cos 270 plus theta, then tan 270 plus theta. 90 degree, 270, then after that 180 degree and 0 degree, okay? Then one thing you kept in mind, that when 90 degrees there, either positive or negative, plus or minus, 90 minus or 90 plus, sine becomes cos and cos becomes sine, and tan becomes cot. In the same way, for 90 plus also, sine becomes cos, cos becomes sine, tan becomes cot. For 270 degree also, both 90 and 270 degree, sine becomes cos, either 270 minus theta or 270 plus theta. Cos becomes sine and tan becomes cot. Now if you remember these points now, you can easily remember all these formulas. Only have to just remember that in first quadrant all trigonometric ratios are positive, second only sine is positive, third only tan is positive, fourth only cos is positive. So I'm going to write the formula for this one. Now what is the formula for this one? Sine 90 minus theta. In which quadrant 90 minus theta? 90 is this one. 90 minus theta means first quadrant, and in first quadrant all trigonometric ratios are positive. It means sine 90 minus theta, sine becomes cos theta, right? Cos 90 minus theta, sine theta, and tan 90 minus theta, cot theta, and all are positive. All are positive. In first quadrant, all terms are positive. Now sine 90 plus theta. First, when 90 is there, sine becomes cos theta. First you write cos becomes sine and tan becomes cot. Now you have to put sine. Sine 90 plus theta is in second quadrant, right? In second quadrant, only sine is positive. All others are negative. So only sine 90 plus theta is positive, then others are negative. Cos 90 minus theta negative, tan 90 minus theta negative. In this way you can learn these formulas. Same way for 270 also. 270 minus theta in which quadrant? Third. In third one only tan is positive. So first you write sine 270 minus theta becomes cos theta, cos becomes sine theta, and tan becomes cot theta. Okay. Now you put sine. In third quadrant only sine is negative. Now only tan is positive, right? Cos is also negative, tan becomes positive. This one is negative, this one is negative, this becomes positive. Now 270 plus theta. 270 plus theta is in fourth quadrant, and in fourth quadrant only cos is positive, right? Others are negative. Sine becomes cos, you write cos theta, cos becomes sine theta, and tan becomes cot theta. But only cos is positive, others are negative. Put sign like this one. In this way you revise these formulas for 90 and 270 degree. Okay. Now next for 180 degree and 360 degree, right? In the same way, sine 180 minus theta, cos 180 minus theta, tan 180 minus theta. Then in the same way, sine 180 plus theta, cos 180 plus theta, and tan 180 plus theta. After 180, then 360. Sine 360 minus theta, cos 360 minus theta, tan 360 minus theta. Okay, then 360 plus theta, again you written back in the first quadrant, which you already written 90 minus theta for, right? So here in this case 180 degree and 360 degree trigonometric ratio becomes same, remains same. Sine always sine, cos cos, tan tan. So it's very easy just to find in which quadrant these values, these angles lies. Okay, so 180 minus theta means this one is 180, 180 minus theta means second quadrant, right now? And in second quadrant only sine is positive. So sine 180 minus theta, just write sine theta, cos 180 minus theta, cos theta, tan 180 minus theta, tan theta. It does not change. Sine remains sine, cos remains cos, and tan remains tan. Now in this 180 minus theta second quadrant only sine is positive. This one is positive, others are negative. In this way remember the formula. Same, next 180 plus theta, it means third quadrant. Again you write sine 180 plus theta, it means sine theta, cos 180 plus theta, cos theta, tan 180 plus theta, tan theta, right? But 180 plus theta is in third quadrant. Here only tan is positive, others are negative. Sine is also negative, cos is also negative, only tan is positive. Hope you understood these tricks. Then 360 minus theta. Next one is, this one is 360. 360 minus theta means in fourth quadrant. And in fourth quadrant only cos is positive. So just write sine remains sine for 360 and 180. Cos remains cos theta and tan remains tan theta. Okay. Now 360 minus theta is in fourth quadrant. Only cos is positive and sine and tan is negative. In this way you write these formulas. Same way, sine 360 plus, you can write 360 plus theta, cos 360 plus theta, tan 360 plus theta. Here also sine remains sine, cos remains cos, and tan remains tan. and 360 plus theta is in first quadrant. In first quadrant, all are positive. It means sine 360 plus theta is positive. This one is positive, this one is positive. Okay. In this way, you remember all these formulas. 360 plus theta means that you return back to its original position in first quadrant. Starting from the first quadrant, sine 90 minus theta, all are positive. Again, return back to first quadrant. It means you in one round, how much angle you have completed? 360 degree. 360 degree means 2 pi radian. It means after 2 pi angle, the values remains same. It does not change. 2 pi, then again next circle, it means next 2 pi, it means 4 pi, right? Then 6 pi, 8 pi. After completing one complete circle, it means 2 pi radian angle, the values remains same, right? So you can write in this way, okay? Okay. 2n pi plus theta becomes what? It becomes theta. N is an integer, it may be n is 1, 2, 3, dash, dash, dash. If n is 1, it means 2 pi, n is 2 means 4 pi. So again 4 pi plus theta again becomes theta. 6 pi, 3 means, n means 3. So 6 pi plus theta again becomes theta. You can write in this way, just suppose sine 2 pi plus theta. So 2 pi again come back to its original position, first coordinate. So 2 pi plus theta again becomes what? Same, sine theta. Cos 2 pi plus theta, this again becomes cos theta. Tan 2 pi plus theta becomes tan theta. So you must remember this one also, that after 2 pi angle, right now the values remains same. If 2 pi, in place of 2 pi, sine 4 pi plus theta, it remains sine theta. Cos 4 pi plus theta, then again cos theta. Or 6 pi, 10 pi, 100 pi, even multiple of pi, it remains same. So in this way, this one is also very, very important, that after even multiple of pi, it means 2 pi angle, the values remains same. Okay. After that, one thing is also very, very important, when sorry, when angle is very, very small. It is used at many places when you are solving questions in physics. When angle is very, very small, then sine theta becomes theta, cos theta becomes 1, and tan theta becomes theta. When angle is very, very small, it means between 0 and 10 degree, or you can say 20 degree. When angle is very, very small, you always use sine theta becomes theta, cos theta becomes 1, and tan theta becomes theta. So this topic is also very, very important, trigonometry. All these formulas is used whenever you are solving questions in physics. So you must remember the tricks. In first coordinate, second coordinate, 180, 270, 360 degree, it becomes same or changes everything. If in place of sine, reciprocal of sine is what? Cosec. So cosec 90 minus theta, cos reciprocal sec theta. Reciprocal of cos is what? Sec. So sec 90 minus theta, again cosec theta. In this way, you can make many formulas, right? Okay, I'm going to solve one example. It will be more clear with the help of that example. Okay, mirror this one. Take a screenshot first. Okay, suppose you have to find values for sine 120 degree. If angle is greater than 90, up to 90 degree, you remember the values. But if 120 degree, how you find the values of 120? In that case, these formulas are used. Okay. So sine 120 degree, you can write sine 90 plus 30 degree, right now. And sine 90 plus theta is what? 90 is there, it means cos theta. And 90 plus theta means in which coordinate? Second coordinate. Second coordinate, sine is positive. So it becomes just cos 30 degree. And cos 30 degrees, value of cos 30 degree is what? Yes, root 3 by 2. You can also write in this way, sine 120 degree equal to sine 180 minus 60 degree. In this way also you write. For 180, sine remains sine theta. And it is in which coordinate? Again, 180 minus theta is in second. In that case also, sine is positive. So, sine just plus sine 60 degree. And sine 60 degree is also root 3 by 2. So, values remain same, whichever formula you are using. But just trick is, remember these tricks, okay? So, in this way, sine 120 degree, suppose sine 145 degree, okay, cos 155 degree. Any values are there, you can easily solve with the help of these formulas, okay. After this, I am going to start calculus. Now, I am going to start calculus. In that one, first differentiation. What is differentiation? I think it's new for you class 11th and 12th students. It's very, very important for class 11th, 12th physics. So, what is the meaning of this differentiation? Suppose y is any function of x. This is function and this function may be constant function, logarithmic function, exponential, algebraic, any function, right? And this function changes with x. It means x here is independent variable. It can take any value, right? And y depends on x. Y is dependent variable. If the value of x changes, y also changes, right? And how this y changes with respect to this x, that is differentiation. If change is very, very small, you can say instantaneous change. For small change, you use the word instantaneous change. For instantaneous rate of change, differentiation is used. If the change is very small, for that one differentiation process is used. And its symbol is, suppose d, it changes with respect to suppose x, and y is any function fx. So this is the symbol for differentiation, dy by dx. Y may be any function. In place of y, it may be constant function, exponential. Okay, I will discuss with the help of examples, right? So this dy by dx, or you can write simply dy by dx, right? This is differentiation of y with respect to x, or instantaneous rate of change of y with respect to x. When x changes, y also changes. When the change is very, very small, for large change we use average, right now, delta symbol is used. But for very small change, instantaneous change, we use a small d. Small d is for differentiation, right? So this dy by dx, is going to write derivative of y with respect to what? X. It is related to x variable. It alone does not exist. It always depends on some variable. And here x is the variable. And y changes with x. So y is independent and x is dependent variable. So dy by dx is the symbol of differentiation, and y is any function, right? And how that function changes with time, you can simply write derivative. Its meaning is derivative of y with respect to x, or instantaneous rate of change of y, WRT is with respect to x. its meaning is this one. Okay, and when you study chapter 3 now, motion is straight line, chapter 4 motion in a plane, in that case this differentiation is very important where it is used, right? So okay, now this is mathematical meaning, another is geometrical meaning. It has two meaning. This one is mathematical meaning, right? Mathematical meaning of differentiation. And what does it mean? Instantaneous rate of change of y with respect to x, dy by dx. Now next is geometrical meaning. What is its geometrical meaning? Why it is used in physics, right? Geometrical meaning. So geometrical meaning of this differentiation is slope. And slope, you heard this word slope, right? Now slope is nothing but how much a straight line makes some angle with the x-axis. Suppose this one is x-axis, this one is y-axis, right? And suppose motion is any motion. Suppose for uniform motion, this is a straight line, so it makes angle theta with the x-axis. Not theta is slope. Slope is what? Tan theta. Tan theta is slope. Okay, so in this case, if it is a straight line, it means motion is uniform, so slope is constant. Na? Theta is constant at every places. Here also theta is constant, here also theta is constant. It means its value is same at all points, right? But if it is non-uniform motion like this one, suppose like this one, so how you find the slope? Here there is no straight line, so you have to draw one tangent at this point which passes through this point, right? And it touches with the x-axis, it makes angle theta. Now you can easily find slope. It means what is the value at this point, and this point it means change is very, very small. Right now for that one, this slope is nothing but differentiation. Differentiation is for very small change, instantaneous rate of change, very small interval of change. And for non-uniform motion, this represents instantaneous change. Okay, because if you take the 2 points, in between these two there is, it does not passes through this curve, so you can't measure this one. You only find in case of non-uniform motion instantaneous value. For that one you draw one tangent, and how much it makes with the x-axis, that gives you slope, tan theta. Here if you want to find tangent instantaneous value at this point, so you draw one tangent at this point also, right? It makes angle theta. Okay, here theta is same for uniform motion, but non-uniform motion theta is different and different places, it means its value changes. It is for non-uniform motion. Here is suppose y and this side x or t, any function you take. So y changes with x like this one. So this slope or tan theta is nothing but instantaneous value at a particular point. It is differentiation. So in geometrical meaning, differentiation, or you can say dy by dx, is nothing but slope, or you can write tan theta. Okay, right? So now you are going to use different differentiation of different functions. So what is the formula for that one? So please take a screenshot. After that I will discuss different formulas and how you use that formula. Now first is, if function is any constant, it means y is any constant, c may be 2, 3, 4, 5, any constant value, then differentiation of that constant is what? 0. d by dx of that constant is always 0. For example, suppose any differentiation of 5, right? So differentiation of 5 is what? 5 is a constant, 0. Differentiation of suppose 10. Differentiation of 10 is what? 0. Differentiation of any constant is always 0. So this formula is important. Many places it is used. Second one is, if function is x to the power n. X to the power n, then differentiation of this x to the power n is n x to the power is n, so write n here, then x to the power n minus 1. This one is also very, very important. 1 or 2 formula is only used. There are so many formulas, but only 1 or 2 formula is used, right? And from that one, this formula is very, very important. It It is used at many places, many times, right? For example, suppose x to the power 2, x square is there. So you know x to the power n is what? N, x to the power n minus 1. So x square, n is what here? 2. 2 and then differentiation of this what? X to the power n minus 1. It means x to the power 2 minus 1. So 2x, 2 minus 1 is 1. So 2x. So differentiation of x square is what? D by dx you write here. Differentiation of x square is 2x. Another example, suppose differentiation of x to the power 7. So x to the power n is n, x to the power n minus 1. So here 7, x to the power 7 minus 1 is 6. In this way you solve. This formula is very, very, very important. You note down and remember it also. This one is very, very, very important, right? Okay, one more. Differentiation of, tell me the answer. X to the power, suppose, okay, in place of x, 1 by x to the power 5. Then in this case, what is the formula? 1 by x to the power 5 means what? D by dx. You can write this power in the numerator, x to the power minus 5. 1 by x to the power 5 means x to the power minus 5. And then you use this formula. So it becomes what? Power is minus 5. So minus 5 x to the power minus 5 minus 1. It means minus 6. Or you can write minus 5x by 6. In this way you solve this one. Okay. So this formula is important. X to the power n equal to n x to the power n minus 1. Next is, if function is like this one, differentiation of any constant into x, any constant. So you always take constant outside, and differentiation of x is what? 1. So if any constant is there with x, you just write simply constant. For example, differentiation of 5x, it becomes 5. Differentiation of 6x, it becomes 6. Differentiation of x is 1, and you always take constant outside. If differentiation of, suppose differentiation of 5x to the power 6, then 5 is constant, you take 5 outside. X to the power 6 is what? 6x to the power 6 minus 1 means 5. So into 6 x to the power 5, it means 30 x to the power 5. In this way you solve. You always take constant outside and differentiation of this function. If x is there, it means it is 1. So this formula, this first 3 is important. Fourth one is differentiation of exponential function. E to the power x is e to the power x. Log function, log x is always 1 by x. Sine function, sine becomes cos. Differentiation of cos becomes sin x. Differentiation of tan x becomes sec square x. Then cosec x. Here sine becomes cos. Here cosec becomes cos minus cosec x cot x, right? Here minus sign is there. Then differentiation of cos x is minus sin x. Here differentiation of sec x is sec x tan x plus sign is there. And differentiation of cot x is tan is sec square x, cot x is minus cosec square x. So you have to revise all these formulas. Just okay, it's very, very important. After this, there are one or more rules are there for differentiation: addition rule, chain rule. I will discuss that one. First, take a screenshot. Are different rules. First one is addition rule. If there are two functions and both are added, then how you differentiate this one? You just differentiate the two functions separately and put addition sign here. If it is subtraction, then you put subtraction here, right? So this d by dx function is u plus v. So first you take differentiation of first function du by dx plus differentiation of second function dv by dx. If it is minus, then you put here minus sign. For example, suppose d by dx of x to the power 5 plus 2x cube. You have to differentiate this one. So you just differentiate these two separately. D by dx of x to the power 5. So d by dx of x to the power 5 you write here. Then d by dx of what? Second function 2x cube. You write here 2x cube. Now, what is differentiation of x to the power 5? 5x to the power 5 minus 1 is 4 plus differentiation of 2x cube. 2 is constant, you take 2 outside. X cube, what is differentiation? 3x square. So 2 into 3 is 6 here. 6x square. In this way, you apply addition rule and differentiate the two function. More than 2 or 3. If there are 3 function, then just add differentiation of third function. Fourth function, differentiation of fourth function in this way. Next one is multiplication rule. If there are 2 function and both are multiplied each other, u dot v. In this case, you take u as first function, v as second function. Now, how you differentiate? Differentiation of these two functions is first take first function outside u and differentiate second function dv by dx, plus you take second function outside v and differentiate first function du by dx, right? For example, you can take example x sine x, right? X dot sine x. There are 2 functions. Then how you differentiate this one? d by dx of x dot sine x. X is one function and sine x is another function. Now you take first function outside. So you take x outside and differentiate second function d by dx of what? Sine x. Plus you take second function outside sine x and differentiate first one. First one is x. So dx by dx. Then answer becomes x differentiation of sine x is cos x plus sin x and differentiation of x is 1. So plus sin x. This is the answer for this one. If the 2 functions are in multiplicative, then you take first function outside, differentiate second one, plus second function outside, differentiate first one. In this way you solve it. Apply this rule. Next, after this division rule, you can say u by v method. If there are 2 functions in numerator and denominator order, then how you differentiate? So first you take square of the denominator. Denominator v is there, right? So take a square of v square. Square of denominator is v square. Then in the numerator, you take denominator right here v and then differentiate numerator du by dx minus. Then take numerator and differentiate denominator u dv by dx. In this way you apply this rule. For example, suppose d by dx of any example you take. Suppose sine x, or you can say suppose in the numerator anything x square by sine x. Sine x is in denominator, right? Then how you differentiate this one? So in the denominator sine x is there, you take sine x whole square, sine square x. Then here you write denominator sine x and differentiate numerator x square. So differentiation of x square, you know, just differentiate it minus. Then write numerator x square and differentiation of denominator sine x. In this way you differentiate, and you know differentiation of x square is what? 2x. So 2x sine x minus x square. Differentiation of sine x is cos x by sine square x. In this way you apply this rule, right? So in the last one is chain rule. If there are more than 2 or 3 function, 2, 3, 4, 5, one is a function of another is function of next one, how you apply this rule? Let y be a function of u. It is not a function of x. Y is a function of u and u is a function of x. And then you have to find dy by dx. For that one, y is a function of u, so dy by du into, then u is a function of x, then du by dx. In this way you apply this rule. It will be more clear with the help of an example. Suppose you have to differentiate under root x square plus 1. Under root x square plus 1 means x square plus 1, 1 by 2. Not x to the power n, x square, x cube, here x plus 1. There are 2 functions inside this one. So first you imagine that it is whole is 1 term, x. And you know x to the power n is what? N, x to the power n minus 1. So you just write power is here half and then x plus x square. Sorry, is the x square plus 1 whole term, you imagine that it has x. So half x to the power n minus 1. So half minus 1, right? Then this is not a single term. No? There are two terms. Then you differentiate these two terms separately. X square plus 1. Then it becomes half x square plus 1 power half minus 1 is minus half. So it comes in the denominator. Minus half denominator under root x square plus 1. And then differentiation of x square plus 1, you apply addition rule. First x square is 2x and differentiation of 1 is 0. So it becomes only 2x. So this 2 cancel and answer becomes x by under root x square plus 1. Right? Is it clear? Okay. One more example. E to the power 2x. Differentiation of e to the power 2x. Not power x. Differentiation of e to the power x is just e to the power x. Na? So imagine that this power is one term. E to the power 2x is e to the power 2x. But it is not only x, na? 2x. So again differentiate this 2x. Right? Then it becomes e to the power 2x. Differentiation of 2x is 2 only. Right? So in this way you solve. Okay? Don't confuse. At most of the places this chain rule is also applied. So these are different rules. It requires practice. If you practice these rules, it can easily be used. Okay? Okay, take a screenshot of this one. After that, I will discuss one small topic in differentiation, that is application of derivatives. Note down please fast. Okay, now application of derivatives, where it is used. Suppose there is a graph like this one or a graph like this one. Here it becomes maximum, it becomes minimum. And you know, suppose this side y and this side is x. Okay. And here at maximum point, you know, if you draw one tangent at this point, it becomes parallel to x-axis. It means here slope is 0. It means dy by dx is what? Dy by dx is nothing but slope. It's geometrical meaning, I already told. Here again at this point, minimum point. If you draw one tangent, it becomes parallel to the x-axis. Here again slope is 0. It means dy by dx is 0. So if suppose y is given, y is something, let it be x cube plus x. Okay. And you have to find the value of x at which this y is maximum or minimum. Here is the value of this x. This is the value of x at which this y is maximum. So at maximum, how you find the value of unknown quantity x at which y is maximum or y is minimum? You just differentiate this one with respect to x, because right now at maximum and minimum, at maximum and minimum, slope is what? 0. It means dy by dx is 0. And if you put dy by dx equal to 0, you can easily get x, value of x. Suppose what is differentiation of this one? D by dx x cube plus x. This becomes 3x square plus 1. And if you put equal to for maximum minimum 0, from here you get the value of x. You can easily calculate 3x square equal to minus 1 and x equal to minus 1 by 3. And right now in this way you calculate the value of x. Now the question arises, if it is this value at this point, x is either maximum or minimum, right now? But when it is maximum, when it is minimum. For that one, again, after calculating dy by dx, you have to again differentiate that d1 by dx once again. It is called second derivative. You can also write it d2xy by dx square. Again, differentiate this dy by dx, and if this is positive or negative, okay? If this is positive, then it becomes maximum, and if it is positive, then value of x becomes minimum. And if the value of this d2y by dx is negative, then the value of x becomes maximum. In this way, you find at which point value is maximum or minimum using this derivative, and whether it is maximum at that point or minimum at that. For that one, you again differentiate that derivative. It means second order differential. This is called second order differentiation. Differentiate 2 times one function, then you get d2y by dx square. So here in this question, here the value of x is what? Negative. So negative value means at x equal to what? 1 by root 3, value of y is maximum. If value is negative, it means it is maximum is there. This is for maximum and this is for minima. If value of d2y by dx is positive, then minimum value, negative, then maximum. In this way solve. Please take a screenshot of this one. Now next one is integration. This topic is also very, very important. Integration is just reverse of differentiation. It is also called antiderivative. It is also antiderivative. So it's very easy to remember the formula. It is just reverse of differentiation, right? It is used for addition of large numbers. If you want to add large numbers, then you have to use integration, right? The symbol for integration is this one. And this integration is also of 2 types. One is definite integral and another one is indefinite integral, right? So what is this integration? First, suppose that if it is uniform motion, graph is like this one for uniform motion. You can easily calculate the area under this graph. Na? This is straight line. You just take area of triangle. You can easily calculate the area of this straight line. Here is y, here is x. But if it is non-uniform motion, then how you calculate the area under this curve? It's very difficult to calculate. For that one, what you have to use? You just take you just cut small strips of length dx. This one is dx and this one is y, and the area of this small rectangular strips is what? Area is what? Length into breadth. So area of this one is y into dx. Again you find area of these small strips. Again this one is y into dx. Again this one is y into dx. In this way you just calculate the area of all the small strips and add all these areas. You get total area. Suppose this first strip here is y1 and this one is dx. Again second strip is this one is y2 and this side dx. These small strips you cut and you add total area. So y1 dx plus y2 dx plus dash dash dash. I will take summation sign y and dx. But this value is not accurate, right? For accurate value, because some space is left here, if you cut the small strip, some space is left here. So it does not give accurate value. For accurate value, just suppose this one is 0 and here this point is suppose this value is suppose 2. So 0 to 2, you have to find the area. What you have to do, you just integrate 0 to 2 of this y of dx and it gives area, right? This is integration of y with respect to dx, and integration of y with respect to dx gives area. Integration represents summation symbol, right? Like now differentiation, it gives slope now, slope of y with versus x, and this integration gives area of y versus x, and this gives slope of y versus x. So differentiation gives slope for instantaneous change. Differentiation, symbol for differentiation is what? dy by dx, derivative of y with respect to x. And integration symbol is this one. Function is y with respect to dx. It means what? Integration of y with respect to x. Integration of y with respect to x. So you integrate like this one, y dx, length to breadth is area. So integration gives area. and differentiation gives slope. So to integrate anything, again like differentiation, you have to remember some formulas. So I'm going to write all the formulas and with now these are different formulas for integration. First one is x integration of x to the power n. All these are indefinite integral because there is no limit from where to where. Okay, and for definite integral there is some limit. I will discuss that one also after this one. Okay, so these are all indefinite integral. First one is integration of x to the power n dx. Like differentiation of x to the power n is what? N x to the power n minus 1. But in that one power is minus 1. Here power increases. Integration of x to the power n is x to the power n plus 1 divided by n plus 1 plus some constant. C is constant of integration, right? This formula is very important for your class 11th and 12th. It is used at many places. For example, of this one, integration of x to the power 5 dx. What is the integration of this one? X to the power 5 is x to the power 5 plus 1 by 5 plus 1 plus some constant. So x to the power 6 by 6. This is the value for integration of x to the power 5. X to the power 7, tell me. X to the power 7 plus 1 means 8 by 8. X to the power 12. So 12 plus 1 is 13. X to the power 13 by 13. In this way, you integrate different functions, right? X to the power n. This one is very important. Just remember this one, okay? Now second one, if there is some constant, in that case integration constant, differentiation of constant is 0. But here integration of some constant is x, right? For example, integration of 5 dx, okay? 5 is constant, you take 5 outside, integration of this dx is x, so this answer is 5x. But in case of differentiation, differentiation of 5 is what? 5 is constant, differentiation is 0. But integration of 5 is 5 you take outside and integration of dx is x, right? Suppose integration of 7 dx. So what? 7x. Integration of dx is x. So this one is also very important, okay? After this, actually integration is reverse of differentiation. So you know 1 by x is formula for what in case of differentiation? Log x. So here integration of 1 by dx is log x. And there at differentiation of log x is 1 by x. Here integration of 1 by x is log x. Integration of cos x is sin x. Differentiation of sin x is cos x. So integration of cos x is sin x. Integration of sin x is minus cos x. Integration of sec square x is tan x. There differentiation of tan x is sec square x. And reverse, it means integration of sec square x is tan x. Integration of cosec square x is cot x, minus cot x, cosec square x. Integration of sec x tan x is sec x. There differentiation of sec x is what? Sec x tan x. So integration of sec x tan x is sec x. Just reverse of differentiation. Integration of cosec x cot x is what? Minus cosec x. Then integration of ex is e to the power x only. And in case of differentiation also, differentiation of e to the power x is e to the power x. Now next is a x to the power n dx. A is any constant, you take constant outside and you integrate this one x to the power n. So a x to the power n plus 1 by n plus 1. Like example this one. For example for this one is integration of 5 x to the power suppose 7. So here 5 is constant, take 5 outside and integration means dx. And you just integrate x to the power 7. So it becomes 5 x to the power 8 by 8, right? So whatever is constant, take outside, integrate other variables, right? X to the power n dx. If there are two functions, they are added or subtracted, u plus v or u minus v, just integrate separate. Integration of u dx plus integration of v dx. These are all indefinite integral. There are no limits. But if limit is there, for definite integral, there is some lower limit, there is some upper limit. So fx is a function, integration of this one is suppose capital Fx. This is the result of integration, and there is limit also, a to b. So you first put upper limit in this function. In place of x, you write upper value b minus f of lower limit is a, so f of a. In this way, you put upper and lower limits and you get the result. For example, suppose here limit is from 1 to 2, right? And 5x to the power 7 dx. So integration of 5x to the power 7 dx is what? You take 5 outside, integration of x to the power 7 is x to the power 8 by 8, and limit is what? 1 to 2. Now in this question, what you have to do? You just put the limits. So you get the result 5. 8 is also constant, take 8 outside. X to the power 8. In place of x, you put upper limit. So 2 to the power 8 minus 2 to the power lower limit is 1. Sorry. Wait. In place of x, you put upper limit 2. So 2 to the power 8 minus lower limit is 1. So in place of x, you put 1 to the power 8. You put the value of x, first upper limit, then lower limit. In this way, you solve this one, you get the result. Okay. Is there any problem? Suppose in this question, limit is there. Integration of x to the power 5 dx. Suppose 5 to 6. So you just integrate this one, limit 5 to 6, right? You just limit 5 to 6. Now first you put upper limit is 6. So in place of x, you put 6 to the power 6. 1 by 6 you take constant, okay? You take outside, 6 is constant. Then minus lower limit is 5. So in place of x, you put 5 to the power 6. In this way, you get the answer. Okay, hope you understood. So these two formula are very important, and then sometimes you have to put limits also. So this one is also important. You just remember all these formulas. Okay, take a screenshot. So with this, I am going to end the class. Hope you understood all the formulas. You just revise and practice it. Okay. After this, I am going to start in the next video class 11th physics from chapter 2, units and measurement. So you must write in the comment box what type of video you want. One shot video, it means one shot of whole chapter, or 10 minutes small 10 minutes videos. Okay, you must write in the comments box. I am waiting for it. Okay students, up to then please keep revising and stay tuned with this channel. Thank you.